Hi intermediate. I almost called you pre-calc. Hi intermediate. Let's do 4.1, which is graphing. So I'll do 3 types of graphs, 3 kind of different scenarios in 4.1, and then there's, and I believe 4.2, there's a 4th type. So, but I'll get to that when we get to 4.2. All right. So the first type of and this is linear, right? Linear means straight lines. So we're just going to talk about graphing straight lines. I believe this is a review that you would have seen this in like an introductory algebra course. So this one I'll probably just do one video on. We'll sort of get through it quick. So graphing by the intercept method. Graphing by the intercept method means that you're going to use the intercepts to graph your line. Now, if you think about it, how many points, what is the minimum amount of points you need to graph a line? 2, right? You need 2. You need at least 2 points to graph a line. And you could use a 3rd point just like as a check if you want to do that. So when you're graphing by the intercept method, we're requiring you to use these specific 2 points. You can't just use any points you want. You can pick more points than these, but you must have these 2. All right, so this is the x-axis on the horizontal, the y-axis is the vertical. The x-intercept is where you cross the x-axis. The y-intercept is where you cross the y-axis. Okay? Now, if you're doing the x-intercept, the y value must be 0, right? The x-intercept, you have to let the y equal to 0. That's how you do it. The y goes away. For the y-intercept, you have to let the x be 0 because you have to make the x go away or be centered. Okay? All right, let's try an example of that using the intercept method. Actually, let me see if I can squeeze it on here. Again, I'll focus it in a minute. I can see it's going fuzzy. All right. So here I'm going to do the intercept method, which means that I'm going to find the y-intercept, which means I'm going to let x be 0. Find the x-intercept, which means I'm going to let y be 0. So let me start with the x-intercept on this graph. You can either do this in your head or you can write it out. I didn't give you a crazy example. So I'm going to let y be 0 in this equation. Three times 0 is 0, so that just goes away. So we're going to get that x is 3. I did the y-intercept first. I did this guy first. All right, now if we do the y-intercept, now we let the x be 0. We go the opposite way. So I take this equation, I let the x be 0 now. 2 times 0 is 0, so 3y equals to 6. Divide off the 3. That gets rid of that, and you get that y equals to 2. The table is a different way of writing coordinates, so some people prefer to write it as a coordinate. Okay, all right, let's draw this guy. All right, so the first point I'm going to draw is a 0, 2. So that means that I'm right here at 0, 2. The next point I'm going to draw is the 3, 0. So I'm over here at 3, 0. And then 2 points is enough to draw a line. So I can go ahead and draw my line. Let me just get this guy a little better. Okay. and then there's my line. Okay, that's the intercept method. You're always required to have the intercepts on any linear graph. You must show them. There is a requirement anytime you graph the linear cases, okay? So please try to remember that for the tests and the final. All right, that was the first case, so graphing by the intercept method. The next type of graph is when the graph goes through the origin. Okay, if your graph is going through the origin, you can't use the intercept method because you only touch the axis once, right? Because the X and the Y intercept are overlapping, right? They're the same spot. So the intercept method, I don't want to say the word fails, but it's kind of like fails because it doesn't give you like 2 points. So you actually have to find a second point somewhere on your line so that you can draw it, because you need 2 points to get the slant correct, to get the angle correct, okay? So let's try one of those. So what happens when you try the intercept method? Like, let's say you want to find the x-intercept and you let y equal to 0. That goes to 0, so you get that x is 0. So when y is 0, x is 0. So you can see that you're going through the origin, so it's going to be this case. Now there's 2 ways to handle it if it's this case. So if the first way that you can handle it is that you can find a second point. Okay? So that's sort of like weird to people. They're like, well, how do you do that? So for instance, if I just randomly let x equal a value, so let's say I let x equal to 3, or you can let y randomly equal a value. But let's just say I pick 3. You could pick 3, you could pick 6, you could pick 2, it doesn't matter. This drives people a little crazy because they don't know why I picked that. It's random. I could have picked anything I want. Once you know an x value, y is dependent on that x. Once you know once you pick something for x, you can just solve for y. All right, now I'm going to solve for y, so I'm going to move the 3 to the other side. So now I have 2 points because I have the 0, 0, which we knew from the beginning. And now when x is 3, y is negative 1. When x is 3, y is negative 1. Okay, so the first technique you can do is you just sort of find, it's better for me to say find, or even better than that, create. Okay, so once you get the origin, then you sort of create a second point. And again, there's many second points to choose from. There's an infinite amount, actually. The other way to do it is to use the slope. And I haven't really gone over the slope yet, but for some of you, you may prefer this if you remember this, you're familiar with this. But you have to put it in the form of y equals mx plus b. If I'm talking gibberish, just don't worry about this. We're going to get to this stuff. But I'd have to move the x over. Then I'd have to divide off the 3. So y is equal to 1/3 x. So if you remember how to use the slope, you can also draw with that. So this means rise over run. So if I go up 1 and over 3, that will also be a point. And I'll show you that in a minute. Let's draw this guy. Alright, so if we do it the first way, for starters, I'll do it both ways. I'm putting down the point 0, 0, and I'm putting down the point 3, negative 1. By the way, you can always tell it goes to the origin if there is no constant or the constant is 0. Not that you have to memorize that, but if you wanted to know. Okay, so that was by the first technique where I created a second point. Now, if you're the type that wants to use a slope, and again, I'll get into slopes another day. It's not today's lecture, it's section 4.2, which is the next section. But if you do happen to know it, this would be... Oh, did I lose this? I lost a sign here. I didn't realize it. Let me fix that. I was wondering why it wasn't matching up. When I move the x to the other side, I should have made it negative x. Let me fix that. When I move the x to the other side, I should have made it a negative x. Yeah, because I was like, why does that not look right? Okay, so I'm going to make it a negative x. Again, I'll show you this next lecture, but I'm going to keep the negative with the 1, because you're going to notice it's the same point here. So this means I'm going to go down 1 unit and to the right 3. And if I go down 1 unit and to the right 3, you'll notice that's actually the same point that I just created. Okay, so both these techniques work. It's just really what a student prefers to use. Okay, whatever a student prefers to use, and either's fine. I'm not going to force you to use one or the other. Okay, gang, I'm going to wrap up this video. So this was the 4.1 lecture, and okay, hope you enjoyed it. Bye bye.